Have you ever stopped to think about how the internet actually works? I mean, how does a single data packet know if it's meant just for you, or for you and a million other people at the exact same time? Well, it all comes down to a few core methods that act like the internet's very own special postal service.
Seriously, think about it for a second. You can fire up Netflix and stream a movie. That's a piece of content delivered on demand just for you, to your screen. But at the same time, millions of other people can be watching a live soccer game, all getting the exact same video feed simultaneously. How in the world does the network handle both of these scenarios so efficiently?
The answer, turns out, lies in three fundamental ways of delivering data: Unicast, Multicast, and Anycast. And to really get our heads around them, we're going to use a super simple analogy that you already understand: sending mail.
So here's the game plan. First, we'll look at Unicast. Think of this as sending a personal one-to-one letter. Then we'll explore Multicast, which is more like a newsletter that only goes out to a specific list of subscribers. And finally, we're going to unpack the cleverest of them all, Anycast, which acts like a smart global mailbox that always finds the nearest place to drop off your mail.
Okay, let's dive right in with the one you use every single day, probably without even realizing it: Unicast. This is by far the most common and, honestly, the most intuitive method of the bunch. It's our personal letter.
So in technical terms, Unicast is just a one-to-one mapping. A packet of data is sent from a single source IP address to a single destination IP address. It's a direct, private line of communication between 2 points on the network. Simple as that.
And this, right here, is the heart of most of your internet activity. When you browse a website or download a file, your computer is having this direct, one-to-one Unicast conversation with the server that's hosting that content. It's basically a private chat, just between those two devices.
You see it absolutely everywhere. Services like Netflix use Unicast to deliver a personalized stream just for you. Every single click on a website, every file you download, and every private video call you make is a Unicast transmission. It is the default workhorse of the internet.
Now, the big plus here is that it's simple, it's reliable, and it's secure. But it has one major weakness: scale. If you want to send the exact same data to, say, 1,000 people, you have to create 1,000 separate Unicast streams. That just eats up an enormous amount of server resources and network bandwidth. It's just not built for group communication.
So, what happens when you do need to send the same information to a huge group? This is where Unicast just falls flat. To solve this problem, we need Multicast, which we can think of as our subscriber newsletter.
The key idea here is this thing called a multicast group. Instead of sending a packet to one specific device, the source sends it to a special multicast IP address. Any device that wants to receive this data basically raises its hand and subscribes to that group. It's like telling your local router, hey, if you see any mail for that newsletter group, send a copy my way.
And here's where the magic of multicast really happens. The sender sends out just one stream of packets. The network's smart routers then act like automated copy machines. They see the stream, they replicate it, and they forward copies only down the paths that lead to subscribed members. If you're not on the list, you get nothing. It saves a ton of bandwidth.
This is the incredible technology that powers massive live events. When you're watching a live game or a company-wide announcement, you are very likely receiving a multicast stream. It lets one source efficiently broadcast to thousands or even millions of viewers at once without completely crushing the network.
This chart really puts the difference into perspective. I mean, look at this. To send a video to 1,000 people using Unicast, the server has to generate and pay for 1,000 individual streams. That bar is just through the roof. But with Multicast, the source still only sends one stream. The savings are absolutely massive, making it pretty much the only way to do large-scale live broadcasts.
All right, on to our third and final delivery method, which solves a totally different kind of problem. This is Anycast, our smart mailbox. This isn't about sending to one person or many people, it's about sending to the nearest one.
Now, this concept can be a little mind-bending at first. With Anycast, you can have multiple servers, often in different data centers all over the world, that all advertise the exact same IP address. So when your computer sends a request to that address, the internet's core routing system automatically figures out the fastest, most efficient path and sends your request to the server that is closest to you.
So you send your request to just one address, but where it actually lands depends entirely on where you are in the world. A user in Europe gets routed to the server in Frankfurt, while a user in Asia gets sent to the server in Singapore, and they're both using the exact same IP address. The network itself makes the intelligent choice for you. It's pretty cool.
This whole one-to-nearest routing gives Anycast some incredible superpowers. First, by connecting you to the closest server, it dramatically cuts down on latency. This is what makes things like DNS and content delivery networks, or CDNs, feel incredibly fast. Second, it gives you high availability. If that Singapore server goes down, traffic just gets automatically rerouted to the next closest one, and you'd never even notice. And third, it's a beast for fighting off DDoS attacks, because it spreads all that nasty traffic across an entire global network, so no single location gets overwhelmed.
Okay, we've covered the personal letter, the subscriber newsletter, and the Smart Mailbox. Let's put them all side by side to really lock in the differences and see how they stack up.
Let's break this down real quick. Unicast is our simple one-to-one personal letter perfect for personalized content, but terrible at scale. Multicast is our one-to-many newsletter, saving massive amounts of bandwidth for live broadcasts, but it can be a little complicated to set up. And finally, Anycast is our one-to-nearest smart mailbox, which is fantastic for fast, resilient global services like DNS and CDNs. Its main weakness is you can't guarantee you'll stay connected to the same server, which is a no-go for things like online banking.
So why does all this technical stuff actually matter to you? Well, because these systems working behind the scenes form the invisible foundation of your entire daily internet experience.
The thing is, these aren't competing technologies. They're complementary tools in a much bigger toolbox. An Anycast network helps your computer find the address for a website in milliseconds. Your browser then uses Unicast to have a private conversation with that website's server. And at the same time, you might have a multicast-powered live stream running in another window. They all work together, seamlessly, to make it all happen.
So the next time you browse a web page, stream a movie, or watch a live event, just take a second to think about the incredible journey the data is taking. Is it a personal letter, sent just for you? A newsletter for a select group? Or is it a package being sent to the smartest, nearest mailbox? Understanding the difference is really understanding the architecture of our entire connected world.